Okay, today we're going to look at lesson 13. We're still working with the polynomials. Today we're going to look at dividing polynomials using long division. So that's your I can statement or learning objective for today. We're going to do some long division, taking it way back. You've probably not done long division in a long time, but that's okay. I'm going to show you how to do, I'm going to remind you how to do regular long division just with some numbers, and then we'll look at doing it with polynomials. As always, this is a recorded video, so I'm moving faster in it than I would be in person. So feel free to pause, rewind, rewatch, whatever you need to do to make it work for you, okay? I do encourage you to write down the examples and try them with me, just because practicing them with me now will help you when you go to do them on your own in Math Excel. Okay, so this is the kind of problem we're going to look at today. A polynomial divided by a polynomial. But we're going to do it the same way we would divide numbers. So say you were given 492 divided by 4, or 492 divided by 4 that way. Okay, if you're using long division, you'll set it up here like this. Okay. And we need to see how many times does 4 go into 4? 1. So 1 times 4 is 4. Okay. Now, we subtract. So we change this sign. Those cancel. We bring down the next number. How many times does 4 go into 9? 2. So 2 times 4 is 8. Change that sign. 9 minus 8 is 1. We bring down that 2 to make 12. How many times does 4 go into 12? 3. 3 times 4 is 12. We change the sign and we get a 0. So we have 123 remainder 0. Okay, so that means 4 and 123 are factors of 492. So we could take 492, we could break it down in a factor tree and have 4 times 123. Okay, so when you divide and get a remainder of 0, that means those two quantities are factors. Okay, so 4 and 123 are factors of 492. Now, we're going to do the same thing with a polynomial. I started off with an easy polynomial that we could factor and get our two factors, but I'm going to show you how it works with the long division. So we're looking at the front pieces, so the x and the x squared. X times what gives me x squared? X times x. Okay, so I'll put that here. So x times x is x squared. X times 3 is 3x, okay, because you got to multiply it all the way through. Now, we change the signs. So we change this to negative, we change this to negative. Now we combine. X squared minus x squared is 0. That should work out every time. So if you don't get it, when you multiply, if it doesn't match here, you've done it wrong. If you combine and they don't cancel out, you've done it wrong. Okay? So those should always be the same and then cancel. All right, 5x minus 3x is 2x. We bring down our next term. Okay, now x times what will give me 2x? A positive 2. Okay, so 2 times x is 2x. 2 times 3 is 6. Change the signs. 2x minus 2x is 0. 6 minus 6 is 0. So we have a remainder of 0. So that means that x plus 3 and x plus 2 are factors of x squared plus 5x plus 6. Okay? So today, we're just going to look at the long division by itself. But tomorrow, in some of your problems, you're going to be asked, is this a factor of this? So you have to do long division and see if you get a remainder of 0. So we'll make a little note. If you have a remainder of 0, then you have factors. Okay, that means they go into the larger quantity evenly. All right, so now we'll just practice some long division. So now that we've talked about the factors. Okay, so here's the next one. So we have this quantity divided by x minus 1. All right, so I'm going to remind you how to do it when you get a remainder over here on this side. So we'll use our little numerical problem. Remember, you set it up this way. What you're dividing by goes on the outside. That larger quantity goes on the inside. Okay, so how many times does 3 go into 4? 1. 1 times 3 is 3. Right, change the sign, combine. 4 minus 3 is 1. Bring down the 7. How many times does 3 go into 17? 5. 5 times 3 is 15. Change the sign. Left with 2. Bring down the 6. How many times does 3 go into 26? 8. So 8 times 3 is 24. Change that sign. We're left with a 2. So the remainder is 2. Or it could be written as 158 and 2/3, or 158 plus 2 over 3, or just 158 remainder 2. Okay, so those are all different ways to write your answers. Now, in Math Excel, I think today they're either like this, it has a spot for the answer and the remainder, and then some of them it has a box over the denominator, okay, what we're dividing by. So you're just plugging the remainder in the location it designates. And then I can't remember if they're today or not, but tomorrow they'll be set up as an addition problem. So it's just important that you know your remainder goes over what you're dividing by, and that's it. So now let's practice with the polynomials. All right, so we're looking at x and x cubed. So x times what will give us x cubed? X squared. Okay, so we'll put that over x squared. Okay, x squared times x is x cubed. X squared times -1 is negative x squared. Now, change the signs. You can't forget to change the signs, so change that and change that. Combine. 3x squared and x squared is 4x squared. Bring down that next term. Okay. X times what gives me 4x squared? Well, I obviously need a 4, and then x times x makes x squared. All right, let's check it. 4x times x is 4x squared. 4x times -1 is -4x. Change the signs. So opposite, opposite. Combine. Those cancel. X and 4x is 5x. Bring down that last term. All right, x times what gives me 5x? 5. Okay, 5 times x is 5x. 5 times -1 is -5. Change the signs. 5 plus 5 is 10. So we have remainder 10. So our answer is x squared plus 4x plus 5, the remainder 10. Okay, or remember, you could write the remainder the other way. So 10 or 10 over x minus 1. Either of those will work just fine for us. Okay, here's number 3. Now, one thing that I didn't talk about earlier, and we will talk about more tomorrow, is that you have to make sure you have all of the terms covered inside here. So what you're dividing by, you need to have all the terms. So you need to make sure it's in standard form. And if you're missing a term, you have to fill it in with 0. So right now, we don't have to worry about it because we have x squared, x, and no x. All right, but you couldn't have x cubed, x, and a constant. You would have to put in an x squared term. So we'll talk more about that tomorrow. But just be thinking all of these are set up to where you're not missing a term. They're in descending order. But if you were missing one, you would have to throw in a 0. Okay, so let's work this one out. Again, I do recommend that you pause the video, give it a try on your own, see what you can do, and then check your answers with me. All right, so we're looking at 5x and 20x squared. So 5 times what will give me 20? 4. X times what will give me x squared? X. Okay, so 4 times 5 is 20. X times x is x squared. 4x times negative 3 is negative 12x. Okay, change the sign, so minus plus. Those cancel. 13x and 12x is 25x. Bring down your last term. Okay, 5x to 25x. 5 times what is 25? 5. And do we need an x? No, it's already there. So let's check it. 5 times 5x is 25x. 5 times negative 3 is negative 15. Change the signs. Those cancel. Negative 6 plus 15 is 9. So we have a remainder of 9. So there, your answer is 4x plus 5, remainder 9. Or 4x plus 5 plus 9 over 4x plus 5. Or 4x plus 5 with the remainder 9 over 4x plus 5. You can write it either of those ways. It just depends on, just depends on what Math Excel is wanting from you. Okay, this is the easiest if Math Excel isn't wanting something specific. Okay, but they all mean the same thing. Okay, here's number 4. This one's a little bit different. You've got a polynomial with 4 terms, and we're dividing it by a trinomial, so with 3 terms. So this is a little bit different, but we're going to do it the same way. I think you only have one like this in your homework, and I think it's the very last example, okay? But we're going to follow the same process. So we're looking at those first terms, all right? 3 times 1 is 3. To get from x squared to x cubed, we need an x, okay? So I'm all the way down here at just the plain x's. All right, so x times 3x squared is 3x cubed. X times 2x is 2x squared. X times 4 is 4x. Now, we have to swap the signs. So change that to a negative. Oh, changing that one to a negative and that one. Let's combine. Those cancel. Negative 7x squared minus 2x squared is negative 9x squared. X minus 4x is negative 3x. We bring down that plus 2. Okay. What times 3x squared will give us negative 9x squared? Negative 3. See, negative 3 times 3 is negative 9. X squared. Negative 3 times 2x is negative 6x. Negative 3 times 4 is negative 12. Change all those signs and combine. Negative 3x plus 6x is 3x. 2 plus 12 is 14. And there's nothing else I can do. I'm to the end. So that means my answer is x minus 3 with a remainder of 3x plus 14. Okay? Now, you could write that out as x minus 3 with a remainder of 3x plus 14 over 3x squared plus 2x plus 4. Okay, obviously that's more work. If Math Excel wants you to type it in that way, that's how it works. But that's just what it would look like. Okay, now the last thing that I want us to look at before I let you go is just how to set up your problems. Okay, so if you're given a problem that says 5x squared minus 2x plus 1 divided by x minus 1, then for long division, you're going to write it like this. X minus 1 on the outside, and then 5x squared minus 2x plus 1 that way, okay? Or if it gives it to you in a fraction, say if it was 5x squared minus 2x plus 1 over x minus 1, okay, that x minus 1 is what goes on the outside, and that larger polynomial goes inside. So just a heads up, on Math Excel, it's going to show it to you these ways, and you need to put it in this form for long division, okay? But then you can do your long division of the polynomials and get your answers, okay? And if you have any questions, let me know. I'm happy to assist you with whatever you need. You just have to tell me, hit Ask My Instructor, send me an email, hop back in the Google Meet, whatever you need, and I'll be happy to do it. All right, have a great rest of your day.